Play. We have with us tonight the one, the only, the man, the myth, the legend, Spurskimo. How you doing, mate?
Good evening, good evening. How are you? Fight the Flat Earth. Ironic that your name is Fight the Flat Earth, because it seems to me that you are fighting the obvious. You are fighting what is clear. You're fighting what is demonstrable. But we can get into that. But yeah, I'm
Yes.
glad to be here. Thanks for having me on.
Just
Go
one,
ahead.
just one sec. Just want to welcome Tony Purcell to the channel, the PhD gentleman I was talking about. Tony, do you just want to quickly introduce yourself to Spurs and tell him what it is you do?
Hi Spurs, I'm a research geophysicist, so what I do is I model Earth's gravitational field and shape as a function of time, and I model satellite orbits and their response to mass distributions on Earth's surface and within the Earth.
Okay, nice to meet you. Nice to meet you.
Cool.
Nice to meet you.
We'll get to your questions that you had for Spurs in a minute, Tony. We'll just let Brainy finish the
Yep.
discussion he's having with you.
Okay, so Spurs,
Hi.
the argument, so do you understand that mineral exploration is something that receives a great deal of funding?
Mineral.
Mineral
Mineral?
exploration, yes. Yes, minerals.
Okay.
Okay, so a lot of effort is put into developing techniques to try and work out the location of ore bodies underneath the Earth's surface. Obviously, we can't see them, and drilling holes to work out whether or not they're there is expensive. So the ideal solution is to have some sort of observation that we can perform at the surface that will tell us where there's dense material that probably corresponds to ore bodies. Okay?
Okay. Yeah.
All right. So one of the ones that you're probably very familiar with is seismological. There's another one that's called magnetotelluric mineral exploration that relies on the conductivity of the material. So you generate an electrical field, you look at sort of the return electrical field that results in Earth's interior, and then you can sort of work out where conductive material is. But the third one is gravimetric mineral exploration. And the way that works is that we have what are called gravimeters. They're devices that basically measure the extension of a spring that has a test mass on it. And as you move this around, the extension of the spring changes. Okay, there's more force applied. Well, there's more force applied at some points on Earth's surface than at other points on Earth's surface on this test mass. Now, those are the observations. What we do then is we hypothesize that those apparent changes in force are the result of density distributions underneath Earth's surface. And we invert the observations to work out where the density perturbations are and how big they are. And this technique is accurate enough that we can locate subsurface ore bodies. Now, if your theory, if your suggestion that Newtonian gravity is just wrong, that it doesn't work, my question to you is, why does that technique function at all?
Well, you're implying that Newtonian is a pulling force. Is that what you're suggesting?
I am demonstrating that Newtonian gravity is a pulling force, and it is observable.
Okay, so how does that work? What's
Because
the
if it
mechanism behind
weren't, I don't need to explain the mechanism in order to observe it.
Yeah,
Just
I mean,
like
because
you
you
don't
have...
need to.
Well,
You
hold
don't
on a
need to.
second. Excuse me, sir. What's your name again, sorry?
My name is Tony.
Tony, okay. It's chemo, Spurskimo. So, yeah,
Yep.
again, if in nature we have an observation, we have a phenomena, you then obviously would have a hypothesis, yeah? So you're saying because
But I have observations to start with, right?
Okay, yeah. So what did you observe? What was your observed phenomena here?
I was observing the extension of a spring which depends a reference mass as a function of
No, hold on.
location. I
Sorry,
was
sir.
doing it.
So an observed phenomena is something that comes into question, right? So it's questionable, something that you don't quite understand. So what did you see in nature that was
No,
questionable that you didn't?
I reject that characterization completely. You cannot tell me how I have to view things philosophically in order to conduct science.
Well, this is what I'm
You
asking.
don't get
First of
to.
all, what is the question? What is the question you're asking here?
The question I am asking is, can I use variations in gravitational acceleration
Sir,
to
you're presupposing gravity already. I'm asking you about the phenomena in nature that you saw, that you questioned. What did you see in nature, in the natural and physical world?
I saw
Hmm.
variations in the acceleration that objects experience as a function of location.
So you saw something move quicker in one location than another
I
location.
saw it accelerate at a different rate.
Okay. So what are you hypothesizing? What's your predicted cause of this
My
change, this phenomenon?
hypothesis is that that is due to differential density perturbations underneath Earth's surface.
That's your predicted cause to this effect.
Yes.
Okay, so how have you tested this, sir?
I test by drilling in areas where my observations of the
Sorry,
variations in
sorry,
acceleration.
sir, you have a cause to this effect. This would be your independent variable, right? So what do you
Yes.
predict is the variable that caused this?
I'm sorry, I'm going to have to appeal to the other participants in this conversation. I feel I've explained this 3 times already. How do you now, and I feel you're being willfully obtuse in choosing not to understand what I'm saying.
Yeah,
I fully understand what you're saying, but what
Kima,
you're
let me ask
saying to
you.
me is that
Let me ask you a
uh
question. Can you define acceleration, please?
so acceleration would be moving from one point to another.
Excuse
No.
me, what the fuck did you just say?
It would be moving from
What?
one point to another. So you're
No.
timing the
So,
time it
A
takes
chain
from
Every single physics student in the world just had a heart attack.
okay.
delta V, change in
So
velocity.
but
yeah,
that's
and
essentially what you're
velocity.
doing. You're timing the time it takes from one object to get from one position to another.
No, you're not.
No,
Oh my
no,
But if
god.
I'm
it's
not.
accelerating, how do you do that? Because it's not constant,
How
so
do
you
If
have to
how do you
calculate
so,
what?
the change in speed.
How do
so,
you accelerate?
so may
Did you
I?
say?
May I?
Yeah, yeah. Go on,
May
Tony.
I? Yeah. So,
Wow.
so to move motion from one place to a different place is the result of velocity. That's the velocity is the metric for movement. Okay, a non-zero velocity means that the object is moving in our chosen reference frame. Okay, acceleration is the rate of change of velocity. Okay, it's the observed change to that. You will be familiar with the concept of speed, for instance. Objects move with a particular speed. Velocity combines speed with a direction. It's a vector quantity. Okay? Does
Sure.
that clarify the situation for you? Okay, so are you aware of Hooke's law?
I've heard of that. Yeah.
Okay, so the extension of a spring is proportional to the force that is applied to the spring. Okay?
Okay.
So if we have a spring that has a mass that is not changing at the end of it, and it has one extension at one location and a different extension at another location, we can infer that we observe that the force applies to the mass at both locations. That's the only way to explain.
I don't see where this is going, because we were talking about science and finding out how the independent variable, and you kind of diverted and went to something else. So
no, so what you are trying to do here is use the Nathan Oakley / Sleeping Warrior attempt to dictate to scientists how they must undertake scientific investigation, and I am not going to accept that you get to do that because you don't have any authority to.
Well, sure, but I still want to know how you know something then. How did you come to the conclusion without testing the cause to the effect? Did you guess?
Okay, I did. So let me explain to you how the scientific method works. Okay, there's a phenomenon that you observe. In this case, it's extension of the spring from which the mass depends. Okay, we develop a hypothesis as to why that might be occurring, and we say, okay, if that hypothesis is correct, then we would expect this. Okay, and then we go and test that and see whether or not we were right. Okay.
Right about what, sir? But right about what? What's the question?
Right about our hypothesis.
What was the question, sir?
Chemo, he's just saying this is how it works in general. He's
yes,
not
but I'm saying that why would you come up with a the question?
The hypothesis is the question. They are testing to see if the hypothesis is correct.
So my question is, why is the spring why does the spring experience different forces at different points on Earth's surface?
Why does it experience different forces? So there is a cause to why this happens. What is that cause?
That's the purpose of the experiment.
Okay, that's what we're doing. That's correct, sir. So that's why we don't know what the cause to why there are different springs.
I'm going to interrupt you there. I'm going to interrupt you there.
Sorry.
Because of the people in this conversation, I am the one with the academic qualifications who is published in a peer-reviewed journal and who is employed as a professional scientist. So any assertion that you make, like that's correct, or
sir, I am merely but a student asking questions.
No. You are attempting to arrogate to yourself an authority that you do not have.
Sir,
Please
you are the authority.
From that sort
you
of
are the expert, sir. I am asking you merely a question. What was the predicted cause to the effect, sir?
Okay, the predicted cause to the effect, as I have stated 4 times now, is non-uniform density distributions underneath Earth's surface.
So the predicted cause is non-uniform. Sorry, non-uniform.
The gravitational attraction due to non-uniform density distribution underneath Earth's surface.
Okay, so how did you manipulate your cause, sir?
Going to different places on Earth?
Yes.
Right, Schemo, the question you're asking... One sec. The question you're asking is what is the independent variable,
We're asking the professor here. Sir, how did you clarify your question. How did you manipulate your predicted cause, sir?
One sec. Your question is, what is the independent variable, right? That's what you're asking.
We know the independent variable. He's just told us. And I'm asking him now, how did he manipulate his independent variable, sir? Remember, we are just merely but the students.
He's
and
literally
the
told you
here.
about 4 times by going to different places on Earth.
You said, Craig, you told us. I didn't hear anything from the professor here.
Okay, so we take different measurements at different... We take measurements of the extension of the spring at different points on Earth's surface and at different altitudes.
Is that acceptable?
This gives us an array of points. We can
Okay,
also
so we
make
have an
observations
effect, sir,
time.
and you're saying that you took different measurements, and that was the cause to the effect was you taking different measurements, all the different.
No,
Sorry, sir.
nope, that's not what I said at all.
Okay, so I'm rather confused, sir. So we have a cause. We have an effect. Sorry, we have an effect. Sorry, we have an effect. We have an effect. Sorry. So I'm trying to explore the.
No. What you are trying to suggest is because what you are trying to say is that you will only accept this experiment if I can turn on mass distributions under the Earth or turn them off. Now, I can test this methodology. I can do the test that you're suggesting. For instance, I can go into a field, bury a large test mass at a point in the field, and send students out with a gravimeter and say, find the test mass, or tell me if there's a test mass in there in the field, and if there is, where it is. So I can do controlled experiments. But what I was referring to, I can do controlled experiments where I know what the test mass is and where the test mass is. But having confirmed my...
Sorry,
Camille.
sir. Go ahead. Well, I mean, just to make this simple, this is why it's just a very simple process. A few steps. So you're saying that you observe the phenomena. We have an effect. It would be your independent variable. That would be your dependent variable, sorry. So we're looking for the cause to this effect, sir. Just the cause so we can manipulate it and find out why this happened.
Yep.
And he's already explained that.
By taking measurements, he said.
Yeah. And then
that's the
he also explained that they can drill in the particular areas that they are to check the density distribution to confirm the cause of the effect.
Yeah, what is the cause? What's the name of the cause?
Let me take a step back. The cause of the difference in the extension of the spring is different gravitational forces, different gravitational acceleration experienced at different points on and near Earth's surface. Now, here's the thing. You're trying to argue that this entire theoretical field is invalid, that it doesn't obey the principles of observational science. You're attempting to argue that I haven't, that this entire
Sir, I've made
field
no such claim, sir. Please don't put thoughts and words into my mouth. I merely asked you simple questions that you hadn't observed phenomena in nature. I asked you for the cause to the effect, sir, and now you're berated me for something I haven't said about you when I've asked you very simple questions, sir. Why are you attacking me?
Victim card for 500 pop.
Yeah, Jesus.
I don't feel that I have attacked you.
So can we talk about science, sir? I would rather talk about science, and I would rather talk about effects.
Okay, now I shall attack you because that was an idiotic statement to make.
What, sir?
He's right.
That was idiotic and intellectually dishonest. We have been discussing science the entire time.
No, you've just told me I don't want to do this, I don't want to do that, I don't want to do this, when all I asked you, sir, what was the cause to the effect? That's it.
And I have explained that 5 separate times.
I think it's 6.
And then I asked you, sir, how did you manipulate your independent variable? And you didn't answer, sir. How did you manipulate it?
Yes, I did.
So you manipulated by going to different places.
No, you buffoon. I can test it I can test this technique by going into a field and burying test weights in it. And then I can use the methodology I am suggesting is accurate to locate those test objects, taking measurements in different locations.
So the cause is what?
The
Conclusion?
cause is the masses that I have buried in the ground.
So the masses that you put in the ground cause the effect that we see in nature, sir?
No. They cause the effect that is detected in the experiment that I am undertaking. I can then use the results from the experiment to analyze observations in nature, to detect natural ore bodies and density anomalies. And I can do so accurately when I extend my technique this way.
Okay, sir. I mean, I don't think you're quite following the scientific method here, but...
Then,
oh my God! He's a scientist!
Which is exactly what I just said you would say.
Yep.
Well, so you did not. You didn't give me your.
Several minutes. No, shut up. You know, I said you were working towards this argument, and you said, "No, I'm not. I'm just asking questions." And then, 3 minutes later, you're out with this bullshit.
I said I don't think so, sir.
Now, yes. And how would you know? Why would you, why would you have any worthwhile opinion on this?
Well, I mean, I think science is for everybody, sir. I think if there's a method that you can...
No, it isn't. It's for people who are. It's for people who are appropriately qualified and knowledgeable. The idea that it's some sort of democratic process that everybody gets to participate in equally is false.
Yeah,
it's just a false notion.
Quick question, Spurs. How many PhDs do you hold?
Are you saying, sir, that not everyone can do science?
Spurs, 1 sec. How many PhDs do you hold?
Yes, that's what I'm saying.
It's not about me, Craig.
No, seriously. How many PhDs do you hold?
No, seriously, it's not about me.
So can we say less than 1?
It's not about me, Craig.
Right, okay, so this guy has a PhD
in
science, so he is the one that gets to tell you about the scientific method and not the other way around. Do you understand?
Which he's doing so, Craig.
No, then you're going... No, then you said, excuse me, sir, no, that you're not using the scientific method. You do not get to tell an actual scientist with a PhD in his field how to apply the scientific method. He gets to tell your ignorant ass how to do it. Do you understand?
And
let me make another...
He's been telling you.
Let me make another... Let me make another point. This field of scientific endeavor is used by mineral companies who invest a significant amount of money in it to locate ore bodies. Now, if it was inaccurate, unreliable, unrealistic, unscientific, that would not happen. So, observable reality is that this field of gravimetric mineral exploration produces valuable real-world results. Earth doesn't. It's that simple.
Okay, I mean, again, I would definitely question, your methods, sir.
Under what authority do you question his methods?
Well, again, under the scientific method, which is for all.
No, it isn't.
It's for scientists.
No, it's not. So, look, you've already admitted that you don't have any formal training in science.
No, I said it's not about me, sir.
So you admit.
So you don't. So, if you, God forbid, I hope this never happens. If you suffered a serious medical complaint,
he really does.
Would you come to the conclusion that medicine is something that can be done by anybody? That it doesn't really matter. Any Burke on the street can who's watched a few.
Absolutely
I was
not,
going to say,
sir.
you're asking somebody who's probably going to take like red clover or
Absolutely
something
not,
to
sir.
fix it. But
That
continue
would be
forward.
completely
Okay.
ludicrous, sir.
Okay,
Oh,
so
my bad. Sorry.
you understand the value of technical expertise in a field, and you concede
Um,
it.
well, I mean, I think one of the main reasons why we trust the professionals in that field is because they are doing actual physical, practical work there, sir. Whereas what you're
Yes,
describing,
just like the gravimetric mineral explorations are doing tangible, real work in the real world.
but yeah, sir, again, I respect that you're going out there doing work, but finding the cause to the effects without a scientific experiment is not going to give you a conclusion. And that's what we're looking
You
for.
are asserting that you are asserting that it's not a scientific experiment, and you are wrong to do so.
Well, I did ask you, I did go through the steps with you, and what we've concluded is that you've
You
moved
are
from one place.
you are arrogating to yourself the ability to discriminate between what is science and what is not science without any technical understanding of what science involves.
Well, science, it deploys observations in the natural and physical world, and then obviously
No,
testing with
wait,
an experiment.
define natural and physical world in science, please.
The natural and physical world would be anything considered not man-made.
No, that is completely incorrect and an entirely fucking ridiculous thing that you'll keep saying. The natural world means not supernatural, not man-made. Because Quantum Erasure made this fucking idiotic statement that we cannot apply the Coriolis force to anything that's man-made because it's a natural thing. But that's because you all use words wrong. It doesn't mean not man-made, it means not supernatural. So can we work under the correct assumption of that, please?
Well, I mean, I think, we like to be efficient with our time, and if we know that
Irrelevant.
man has built some, if we know that man has built something and there is an effect in that device, we don't have to be curious and ask questions about that device because we know man made it, so man would have caused it.
That is one of the most ridiculous things I've ever heard.
Excuse me, my brain's
So
still shut down.
what
Give me
you're-
a sec whilst it reboots.
What you're saying is that experimental results from the Hadron Super Collider are completely meaningless and unworthy of any sort of investigation whatsoever because that's a man-made device.
Of course not. So
Yeah.
obviously, if you build a
How would
device,
you study anything?
No, I mean, again, it's about the effect, sir. So what is the effect, and what caused that effect?
He's told you.
I know he's told
I
us. I'm
mean,
just saying that
again-
any man-made device. So if you have a man-made device and we have an effect, so we know that nature did not cause that effect, and that's what science is looking for: is how did
No,
nature?
it's not. No, it's not. Science is not looking for how did nature cause that. You are using the word natural wrong. It means not supernatural, not man-made. Stop using it wrong, Spurs. You sound like a fucking
Well, I
moron.
think what we're looking at, well, just to put it, simply, if it's man-made, we know the cause to
No, we don't.
any effect that
No, we
comes
don't.
after that.
Right, like okay, for instance, let's say a man-made artillery shell. Once it is fired from the equator directly north, does that mean that we cannot then apply the Coriolis force to it because that artillery shell was man-made?
Well, what's the effect?
That's not what I'm asking. Am I saying?
Well, that's what science would be looking for.
The,
Is
the
the cause
effect
to
is
the
the
effect.
fact that the Earth is rotating independently of the freely moving object in a reference frame. So
No, science doesn't look for presupposed ideas. There.
no, there's no presupposition. That is the effect.
Well, you
right?
said the
So
Earth is spinning.
Actually,
that's an observational fact.
Actually,
No, that's not a fact.
can I?
Craig.
Yeah, go
Can
on,
I?
Tony.
Yes, it is.
No, that's not a fact. That's an opinion.
No, it isn't.
No,
It
it's a
is
fact.
demonstrable reality.
Okay, so
So,
what is the
for in-
scientific evidence? Okay, science. What is the scientific evidence for Earth rotation?
Just give me 1 sec, Spurs.
Okay.
So
So
Tony, it's cool.
you
I've
can
got this. 1 sec. I've got this.
Yeah, okay, no
If
problem.
the Earth is spinning at one rotation every 24 hours, that means that every hour it has to turn 15 degrees. And if the gyroscope is mounted
That is a
anywhere on Earth,
statement there,
it's going to drift. In today's
I'm asking you
21st
for the
century
scientific
navigation
evidence.
systems, they're
Yes?
using
Hold
what's
on, hold
called
on.
a ring laser gyroscope. It is extremely precise. If we could simply get one of these ring laser gyroscopes, we would be able to prove once and for all that there is no rotation to the Earth. One of the people in the community actually purchased one for $20,000. But what we found is when we turned on that gyroscope, we found that we were picking up a drift, a 15 degree per hour drift.
Thanks, Bob. So,
And then we hit it with a really strong electromagnetic field and destroyed it later, trying to force it not to.
Yeah. So the effect, the noticeable thing that happened was the measurable drift in the gyroscope, and the cause of that effect was
Okay,
the
so
rotation
we saw a
of the Earth.
drift. What does it mean, Craig? We saw a drift. So
It
what?
means
What does
the
it mean?
Earth is rotating because that is the cause of that effect.
No, you're presupposing that.
No,
the
no,
Earth
we're
could
not.
be
We're
something
measuring.
else.
No, it can't
Science
be
is
anything
understood
else.
on that.
We know
It could
how.
be the ether. Well, I'm not going with the ether, but it could be something
That's what
else.
he was trying to prove it was. He proved he couldn't shield it from the ether somehow.
No,
Yeah,
Like,
no,
come on.
something.
No,
Something
no.
was detected.
Spurs, sorry. No, the Sagnac effect is well understood. We know exactly how light works, and we know what could affect the light inside of a.
Well, I'm not about to get
gyroscope,
into the ether argument, Craig.
Right, but no,
I don't know.
Okay, Greg,
I'm ignoring it anyway because the ether has been disproven, so it's a completely
Well, I
irrelevant
don't
thing
argue
to
the
talking
ether.
about.
I mean,
Right,
there are other flat
Greg, I got to run,
earthers,
bud.
All right,
Hey,
Brainy,
Spursky?
thank you for
Yeah, I
coming
got to
on.
run. Thank you for
Nice to
having
meet
me,
you.
man.
Take care.
Yeah, Spursky, nice chatting with you, bud. Sorry, I
Thank
forgot
you.
the other gentleman's name. What was his name?
Tony Purcell.
Tony.
Yeah.
Tony.
Nice to meet you,
It
Brady.
was a pleasure listening. Yeah, it was a pleasure listening to the information you had there, Tony.
Thank you.
Thanks much.
Yeah. Right, so
Talk to you guys later. Have a good night, guys.
see you later, Brainy. Right, so Spurs, the only thing it can measure is rotation of what it's on, and the fact that it
No,
measures
again,
it
you're
in
presupposing
we're
that,
not
right?
presupposing anything. That's how the devices work. That is their function to
No, the
detect
device
what
is
was
picking
going on.
up something. We don't know what.
We know exactly what I've explained to you many times how a fiber optic gyroscope works. Do you want me to go through
That
it
is
with
not
you
a
again?
scientific experiment, Craig.
Yes, it
It's not
absolutely
science.
is. No, it absolutely is because they
What's
wanted
the
to find
independent variable?
the independent variable would.
Again, we're
First
back
of
to
all,
the
what was observed
again.
phenomena, Craig?
I'm speaking. Again, we're back to you asserting that you have been anointed as the ultimate arbiter of what is and is not science and what can and cannot be accepted. And you're very, very specific about this. Science has an explanation for how your computer works, and you accept that. But other devices that other people have worked on, you don't accept. So you're actually, you've not got a consistent position on the nature and character of modern science. There are just bits that you are ideologically opposed to, and whenever the conversation drifts near them, you start going, well, that isn't scientific. That isn't well established. That instrument isn't measuring what you say it's measuring. This, that, and the other. But apparently, the rest of science is fine. Doesn't have that problem.
So, again, all we have with technology is bits and pieces, parts being put together, engineered. This is not scientific in any way, shape, or Craig, I can't even finish my point. I let Sir finish. Tony here finish.
Sorry,
I want to respond. I can't even respond.
I know,
is it worth me even making points?
You just
I
keep
don't know.
asserting things though that have no backup.
But I'm just giving my opinion, my viewpoint. If I'm wrong, the
Okay.
professor here will correct me, right?
And he keeps
Okay.
trying. All right, I'm sorry.
I'm always
carry
looking
on.
for correction, right? Always
Carry
looking
on,
for correction.
Spurs.
Okay.
Always
Carry
looking
on,
for-
Spurs.
Right.
I'm sorry for
So,
interrupting.
to me, the idea would be that you see parts, you see bits. You would have a clever guy or someone smart, or maybe not so clever, not so smart, but they're able to put pieces of the puzzle together to form something that is working and coherent, and then we can use that working device for other means. It doesn't mean that it falls into the realms of science. Science deals with, and only, the natural and physical world. We've observed phenomena where we have a cause, we have an effect, and we want to know the cause of that effect. So for you to say that computers or anything that's built by man is nothing more than engineering, for me, sir, that's questionable.
But Spurs, I just explained to you
I'm
that you're
sorry.
using that wrong. It's not the natural world as in not man-made. All right, you keep saying that, but I've told you that you are wrong about that. When you're talking about the natural world, it means not supernatural, not man-made. Science applies to man-made things and technology just as much as everything else. Please stop
Okay.
saying it wrong.
Can I ask a question here? I did have a question for you, Spurs. How do you think planes work?
Planes, well, they have an engine, they
Yes.
create lift, they create a
How do they
force.
create lift? How do they create lift?
Oh, I'm not an expert on airplanes, sir.
Okay, it's through the difference of air pressure on the top and the bottom of the wing. So the fact that planes work would tend to contradict your suggestion that there is no such thing as air pressure, wouldn't it?
So, sir, you're saying that pressure at the bottom, pressure at the top. Would an
The
aeroplane
pressure
work underwater,
differential
sir?
between,
Would that work underwater?
yes, it would.
Planes can fly underwater,
And in
sir.
fact, that's not what I said. And I will thank you not to attempt that sort of intellectual dishonesty.
Well, sir, you're talking about pressure, and obviously we know there is water pressure, but the atmosphere would require a force.
Sorry. Yes. And I have told you what the origin of that force is. I have told you can go and you can check, but the whole field of aeronautical engineering is based on the existence of a pressure differential between the top of the wing and the bottom of the wing. This is why wings are shaped as they are, and it is how we explain planes working. Now, if there is no such thing as air pressure, as you have previously maintained, then I would like you to explain how planes work.
So there's a temperature
I would like you
difference.
to.
Temperature,
I
sir,
would like
temperature.
you. That is
As the plane
nonsense.
creates more energy, it creates a force which gives it acceleration. With enough force,
Isn't it?
because of the aerodynamics of the airplane, it would cause it to lift. So this is something they've done since the Wright brothers, sir. They've engineered this through trial and error, and over the years they've perfected the art of flying,
Excuse
sir.
me, what the fuck did you just say again? Oh,
Can
So
I?
since the Wright
So
brothers, when
so.
they've
Can I
always tried
point
to
out?
fly, sir, since man ever existed, sir. Ever since we've seen birds soar the skies, man has tried to
I'll
fly.
have
Now,
you know that birds were
engineering
wiped
that,
out in the 50s and replaced by drones.
so engineering that, sir, proved to be an engineering problem up until around the Wright brothers, sir, until we perfected the art of flying, which is today we can now
Leonardo da Vinci would
fly
disagree,
very
but
high and at all kinds of speeds, sir. Again, nothing to do with
Yes.
science or to do with trial and
do
error,
you
sir.
think do you think saying "sir" makes you right? And
Well,
so,
I'm trying to be polite, respectful, because we do have a professor, we do have an expert, and I am merely
Okay.
but a student
So
asking questions.
just before we go on
okay.
quickly, I
So
just want to introduce Team Skeptic, who has joined the panel to experience the
So I
smackdown that's
Yeah,
probably will have
happening.
around 25 more minutes in
well,
me, Craig.
I
Okay,
I do want to say first, hello, can you hear me?
you can. Hello,
I do
TP.
want to
Hey,
say
yes.
hey,
first, thank you Spurs for referring to me as an expert. I hadn't even introduced myself, and you've already given me a great introduction. So thank you very much for
hey,
that.
hey, team,
I do
I've thought
truly,
about
truly
you
appreciate
coming
it.
onto Jem's channel on Debate, Flat Earth, and more. Have you ever thought about that?
I wouldn't have a
Would
problem
you
with
ever
that.
join? Do you know Jem Panda? He's also a globe earther. He's done. He covered the moon landings. Why we know we went to the moon. Now, obviously, I know we didn't go to the moon.
No, you don't.
But you know, we're kind of buddies in this scene here, and you know, we go at loggerheads constantly about the moon landings. So, have you ever considered joining his channel, discussing the moon landings, Team Skeptic?
I mean, I've never considered it, but I mean, I'm not saying that I wouldn't do it. I just have never, it's never crossed my mind.
But let's
Okay.
get back to the discussion. Team, have you got anything you want to add quickly before we let Tony finish what he was about to say?
Nope, one of my favorite fucking new people in the world. Well, he's not
Yeah.
new, obviously. All that gray, and you could see in his beard. Definitely not new, but one of the new people in my life, Tony Purcell, is an amazing person, and
Yeah.
I have a project coming up that I want to work on with him. It's an absolute killer for the flat Earth. I'm sorry if no flat earther will ever be able to refer to the AE map ever again. They're gonna have to come up with something new. So, Tony, looking forward to that, man.
Yeah.
What,
yeah,
you're going
I'm
to
looking
prove
forward
that
to
the
it.
Earth is not flat? You're going to prove what we observe is not true. How
well,
would you go about
No,
showing
well, hold
that the
on.
horizon herein,
Spurs.
if we have a
Spurs.
globe of 3959, then of course we should have the horizon there in 1.225 times the square root of the observer height in feet. Why is it that we can never measure such a distance to the horizon?
I'm just stepping away from my screen for just a moment. I'll be
All right,
back.
no worries.
Okay.
This is the
Well, see,
question
here's
that
the
is
thing. It's
three-dimensional.
not right. So, like Anthony Purcell said in our last time we talked, and I've said this several times, that trying to use stuff like optical measurements is really, really hard because there's so many different things you have to take into account when
Sure.
you're using an optical measurement. Refraction's one, and we can all agree that refraction actually exists. So it stands to reason that if the Earth is a globe, refraction happens, light will bend around the corner. It's really hard to
Sure.
determine an exact refractive index. So when we're talking about optical like experiments or measurements, we're really talking about a multitude of different things that play into one observation. It's really hard to track down just one aspect of that with so many different variables that can change.
Hey.
With the evidence that Mr. Purcell has is not an optical measurement. It's a physical measurement. It's a measurement of seismological waves around the Earth. So we have an event that happens, and the pressure wave travels away from the epicenter of the event, and it moves at a certain speed. And we can calculate this speed based on whether it's traveling through land or water or, different types of land or anything like that. When we plot these points out on a graph, any one of them that's in the southern hemisphere is going to be a problem for any flat earther that thinks that no southern rotation exists. Because when you plot these out, they form an epicenter circle that crosses the South Pole. So on a flat Earth map, this would mean that you would have a wave that comes in, hits one side of the flat Earth, and immediately appears on the opposite side of the flat Earth before the pressure wave has had a chance to go in the 180 degrees opposite direction. There ends up being a gap where the pressure wave did not travel but seems to have appeared on the other side of the Earth. It works perfect if you plot it across a three-dimensional spherical object. It matches perfect to
I understand.
The energy travels out in a circle.
I understand.
Did I get that right, Tony? Tony,
Yeah,
there was a bit of technical stuff. That's pretty much
right. But team, what I'm asking is, right, an object that has a radius of 3959, then it must mean that every horizon distance must be no more than 1.22 times the square root of the observer height in feet. That's the object
that
itself.
Is false.
Right? What's false about that?
As I said,
that statement
will change
that statement is false. The optical
false?
Your viewing distance to the horizon is a function of atmospheric conditions. So when you say the distance to the edge of my viewing range can be no more than a certain value, that's not true. It depends on atmospheric conditions. I
get that. I get that part, sir. So I understand that. I didn't introduce. I spoke about an object. Yeah?
You said that the viewing distance can be no more than. That
On
statement
the
is
object,
false
sir.
if
On the,
there
I
is.
didn't say a sphere, sir. I didn't say the Earth. I said an object. Well, I did say a sphere,
You
but I didn't
said
say
an
the Earth.
object
To
of
be
radius.
precise.
So
Yeah. So to be
sorry,
clear, I
I
mean
assumed. Sorry, I assumed that you were making a statement that was relevant to Earth. If you're going to make a statement that is irrelevant to Earth, feel free.
Mhm. Yeah, I'm talking about a sphere if it has a radius of 3959, right? A sphere, a spherical object.
Can I?
That's
Can
P.
I just? Can I? This is just a quibble, but please, when you use a number, put the units after it. Because I routinely think in kilometers. When you guys go 3959, I have to. So please, just as a scientific sort of quibble, just whenever you say that, please put miles after it.
3,959 miles, yeah?
Yep.
Okay. So, yeah, okay, so we've got a spherical object of this size, and then the horizon, the distance to the horizon can be no more than 1.225 times the root square of the observer height in feet, right? So, now you're saying that you want to include this spherical object with atmosphere, right? That will,
Yep.
what will that
Yes.
atmosphere do to, okay, calm down. So we've got this object, spherical object with no atmosphere. We see the horizon at the allotted distance. Do we agree, disagree? Agree,
Yep.
disagree? Yep, so we
Yes.
see,
We're talking about a perfect sphere here.
yeah, perfect sphere,
So no topography.
3959.
Yep.
Yeah,
Sure.
we're gonna see an object disappear over that physical. Are we going with the physical horizon, geometric horizon there?
What you have just described is only there are no optical effects. It is a geometric / physical
Yeah,
horizon.
the object, sir. Just the object, sir.
What object are you referring to?
So the object that is of spherical nature. Does the surface depend on your vision, sir?
What?
That question, I cannot parse that question in a meaningful sense.
Okay, so we've got an object. Let's take a basketball, for example. No atmosphere, just the object is 3959 miles, right?
Yes.
So the horizon, when we see it at 1.225 times the square root of the observer height in feet, will that be a physical geometric nature?
I don't think that. So let me make a point here. That statement is an approximation.
No, but
Your
so let's say
formula
we've
for
actually
the your
measured.
form.
No, so there's no presuppositions
No.
here. We have the measurements of the actual size of this sphere object, not the. Well, you can say the Earth if you want, but
Can you let me finish? Your statement
sorry,
of
sir.
1.22 over r squared or whatever it is, that's an approximation. That isn't the actual formula. Do you understand that?
Yeah, I can go with that, sir.
Okay, so that's an approximation. That's just a point. So if you're going to require that it is accurate to absurd levels of detail, I'm going to disagree because that's just an approximation. The actual formulation requires trigonometric functions.
Okay.
I know it.
So do we have any precise number of the radius of the size of the Earth
Yeah.
that we can work with?
6,371.2 kilometers.
Okay. So where would be the physical geometric point for the observer at that point? So let's say if he's 1 foot, 2 foot, 3 foot, how far until the geometric physical horizon?
Well, let's call that distance. Let's call that distance A. Okay, let's call the distance from the where the observer is standing to the point where the observer's eye line is tangent to the Earth. Let's label that point A. and let's call the distance of that arc b. I don't particularly care what the value is. I can calculate it, but I don't have the formula right here in front of me. Team Skeptic might be able to give you an answer more quickly than I could on that. But
yeah, what are we looking for? I'll just do it on a calculator real quick. What
it's not a
value are we
linear
looking for?
function of height.
No, you need to. If you're looking for how far the horizon is, you need to kind of calculate what kind of drop you're expecting to see and where the horizon would be based on that. So
yeah. So anyway, your point is, Spur's point is, there's an observer on a large sphere. There's a distance that they can see before the curvature takes over. Okay. That's fine. There's a finite predictable distance between the observer and where curvature obscures anything else. Okay, we accept that. Now, what's the rest of your argument?
What have we established so far? So do we know where the physical geometric horizon is located?
For a yes, for a known geometry, yes, we do.
Okay, so we have that point marked. Let's apply atmosphere to that geometric physical horizon. What happens after this, sir? What difference will we see? So let's say we're 6 foot, we're looking at the horizon, we see the horizon. Sorry, go ahead, sir.
Okay, sorry.
So rude of me.
That depends. No. Sorry, I spoke before you had finished your question. So if you want to add any more to your question, do feel free.
Well, I'm just trying to establish the difference because we agree we see the geometric physical horizon without atmosphere. Yep. We can locate it.
Yep.
Now,
yep.
Obviously, when we apply atmosphere to that, I'm just curious to know what happens to that geometric physical horizon and what. We get the apparent horizon, I understand that, but in height, in measurements, how can we now determine whether something is obstructed by atmosphere or by that physical geometric horizon there?
Okay,
how do we determine the difference?
Well, you can't, and that's not our evidence that the Earth is round.
Sure.
You know, as you say, provided, you know, sorry, there is an exception. If I know what the atmospheric conditions are with sufficient precision, then I can calculate what the refractive effects are, and then I can do a determination of the relevant significance of both effects. But yes, something, so I don't disagree with what you're saying here, but this doesn't establish that the black swan is proof of a flat Earth, right?
Well, I mean,
the black swan photograph of such fame.
Well, for me, sir, what it does, it falsifies the model of the radius that you've given me. So if you give me a number, a radius, for example, I
would just like to clarify, why do you conclude that the so you have an experiment, and I would say that the results of the experiment are indeterminate. You cannot use this experiment to discriminate between one case. Okay.
It's not an experiment,
but that
sir.
doesn't mean.
It's not an experiment. All we're doing is trying to falsify. We're just trying to falsify. We're going to get your numbers,
yes, and
basically.
You haven't succeeded.
And all we're going to do is verify that the distance to the horizon is what you say it is. All we're doing is verifying your claim, sir.
Now you're being dishonest, right? Because
how so, sir?
Because you just said the distance to the horizon, and it's by no means clear what you're even referring to at this point. Are you
Well, I said,
referring
sir,
to the
initially.
geometric?
Sorry.
Are you referring to the geometric horizon that would exist in the absence of refractive effects? Or are you referring to the apparent horizon that results from a combination of diffraction effects?
Well, so this is what I'm trying to establish and also determine, because if we have no atmosphere and we have a physical obstruction, but we can count for
Yes.
physicality, physical Earth, actual physical Earth of causing the obstruction to the buildings, the CERN, boats, whatever, sir. So if you're saying now, sir, that we've introduced atmosphere and merely we can't see the bottom of something because of atmosphere, I'm just trying to draw the line between
That's
where the physical
that's not that's so that so the that's not what's happening under any interpretation. It's not because of the atmosphere that you can't see the bottom of things. The atmosphere
okay.
allows you the atmosphere allows you to see the top of things that are further away than the geometric horizon. And indeed, it will let you see the bottom of things that are further away from the geometric horizon. But it's not
Okay.
atmospheric effects that are selectively obscuring the bottom of objects.
Well, that's what I'm
Again,
trying to establish.
so Team Skeptics said this, and I said it the first time I came on. The use of optical images, the use of photographs, depends on an accurate assessment of refractive effects, atmospheric opacity, lighting conditions that are around you. There are many ways that
Camera
a
conditions.
photographic image. Yeah, there are many ways that a photographic image can appear to show something that doesn't affect actual physical reality, and the same's true of our eyes. Our eyes are optical instruments, and they have the same propensity for defects. So I would actually suggest that the black swan image does require explanation, and it can be explained. In a number of ways. It does admit multiple explanatory mechanisms, but what I don't think it does is falsify the concept of a spherical Earth. You claim that it does. I claim that it's not. It's not game over either way just because this image exists. And can you? So here's another question for you. If you went to the world's best logician and presented them with the black swan image, would that logician agree with your interpretation?
I'm not quite sure, sir, but I've just sent Craig an image of the black swan. Maybe we can take a look at this together and probably talk about it and try to understand what we're looking at, and try and
Hey,
understand why
can
the
I
black swan
can I
feel
interrupt for a
is such
second?
Yeah, we can hear you.
why
Can
it's
I
such a
interrupt for a
powerful
second?
argument, sir.
Spurs, but Spurs,
Yes.
that's why he asked you if you took, and you kind of blew this question off. It feels like to me that when he said if you took this to a logician, would they come to the same conclusion as you do, based on the evidence you're proposing? And you were like, yeah, sure, and then you just ran past it. No,
No,
a
not
logician
yeah, sure,
would
Team
not come to
Skeptic.
the
I said
same
I couldn't
conclusion.
answer that. I simply couldn't answer. I haven't thought
Oh,
about that.
okay.
I haven't considered
I
that.
thot you said, yeah. So I thought you were
No,
saying,
not yeah,
yeah,
yeah.
he
I
would
didn't mean
come
to
to
be
the
so
same
rude.
conclusion as me. I was
No,
saying,
not
no,
at all.
yeah.
I haven't considered
Okay.
that. I haven't
Yeah, I'm
thought
sorry
about
then.
that. To a magician, again, I don't know how they would see this.
No, a
Again,
logician. A
Not
logician.
a magician.
A logician.
a magician. I mean, again, I'm not quite sure.
Dude,
I haven't thought
Spurs, you
about
kill
it.
me.
I haven't. Again, I'd have to think about that. But the image that I've sent,
do you know what a
Craig, if
do you know what a logician is? LOGICIA it is. Right?
I'm going to take no for 500, Bob.
I'm just gonna see if I'm spelling it right.
Right, so...
Oh, I did. I spelled it right.
Spurs, why don't you explain to Tony what your claim about this specific image is? Let me make sure you're getting a high enough return. I'll put it up to 720. All right, go on, Spurs.
Yeah, you got it on the big screen there. Yeah,
Yeah.
you can see
Yep.
it. You can also,
Yeah.
okay.
Yep.
Okay. So, when you look at this image, what do we observe? We observe a horizon obscure in the bottom of the platforms there, and then we see on a different day we see they're exposed. So, what is happening here? What would you say is happening in terms of the geometric or the apparent horizon of physical nature?
There
So my
is
question is,
there.
my question. The pitch on the left, is that obstruction of physical nature?
Okay, I don't. Well, the observed obstruction is of physical nature. Whether or not the distance to that, whether or not the distance to that object corresponds exactly with the spherical Earth model depends on refractive conditions on that day. Now, my understanding is that the picture on the left was taken when there was standard refractive conditions, but that doesn't mean that refractive effects was zero.
Sure.
Now, can I point out the first time I saw the image on the right? Can I point out what stood out to me?
Yeah.
I normally expect ocean water to get darker as it gets deeper, right, and to get paler as it gets lighter. And what struck me was the pattern of watercolor in this image. Close to the observer, it's pale. Then at that first, it's dark. Then it gets pale again, and then it gets dark again. And that to me indicates that either something really funky is happening with the ocean floor topography here, or the light that is being detected in this photo is undergoing a change in angle before it gets to the camera. So I concluded that this was likely a highly refracted image the instant I saw it, and I noted, and like you've done here, they didn't show the left-hand figure or the pipe towers that are hopelessly bent or that sort of stuff.
Extremely
So
distorted.
I would suggest that this is not the irrefutable logical proof that you suggest it is, and obviously you're not going to just take my word for it, and neither should you. But what I
We'll see
will
about
ask
that,
you
sir.
what I will ask you to entertain is that there are some people on Earth's surface who are more intelligent than you or I, and
Absolutely.
intellectually honest, who are in a position to accurately interpret the logical consequences of this evidence. Now, I obviously think that I am so qualified, but there's no actual obligation on you to share my perception. But I would suggest that if you could find some people whose intellectual ability and intellectual honesty you respect, and just discuss this with them, it would. I think it would help.
So you said refraction. Okay, so I believe
Yes.
refraction is bending of light.
Yes, that's
No?
correct.
Yeah, is that correct? Yeah.
Yes.
So
Yes, that's
when
correct.
thank you. So when you say refraction, there, what is refracting exactly? What object here is refracting?
Okay, so well, I would say that there are clear signs of refraction from the point just in front of the nearest rig, which
Are you
is
talking about on
where
the left picture, sir, or the right picture?
no, the right picture. I would say that
Okay, so
there are obvious refraction effects in the picture on the right from just in front of the base of the nearer rig.
so just to clarify, so
But
the rig on the right is refracting over what, sir? Bending around what, sir?
I'm not. So the light from the base of the rig is refracting around the curvature of the Earth, but the light from the top of the rig is just refracting to the camera. It's not refracting around anything.
So just to be
That
clear,
question doesn't.
the picture on the right, you're saying, so we've got the
Yes.
horizon behind the platforms, behind the physical, or the apparent horizon, sir. Sorry, the apparent horizon is
Yep.
behind
Yep.
the platforms there, and you're saying
Yes.
it's in front of us, but it's refracting. So we know it's 9 miles away, or 6 miles away.
Sorry.
This more maybe.
Yes.
So
Yep.
you're saying but I thought things refracted over the apparent horizon.
No.
No?
No.
So, for example, sir, let me try to illustrate what I mean. So, you see the picture on the left, okay? We can't see the bottom, right?
Yes. Yep.
Okay. So, if say, for example, how to see the bottom of that, we'd have options. We'd have to go higher or closer to see the bottom, right? You agree? Disagree?
Yes. Yep. Yep.
Okay. Okay. So, or that platform would refract up over that horizon that wouldn't change its position. You see, sir.
Yes.
So that
That's correct.
apparent
Yes.
horizon so that apparent horizon on the left there would stay in its position because it's obviously what we measure. We're calculating how much of the platforms we can see. So if we were to see the bottom, like we see on the right, that would mean the platforms would refract up over the apparent horizon, but we don't see that in the
No.
image
No.
on the right, sir.
You're. So
Incorrect, sir.
you're confusing yourself.
Okay, sir, help me, please.
Or you've been confused by somebody else. So
So,
the
sir,
apparent
look, sir,
horizon and no. Please let me
sure,
answer.
sorry,
Let me
forgive me.
respond. Okay. So the apparent horizon on the left is a distance away. The apparent horizon on the right is a different distance away because there are different refractive effects. Now, when you say the apparent horizon, there is you are implying a uniqueness, that they must be the same thing, or that they're directly comparable. That's not true. Okay.
Okay.
And light is, and if you do that, then you can create the linguistic nonsense of then light, the apparent horizon must be refracting over itself in order to get the observer, and that's clearly a logical nonsense. Therefore, the argument falls down. But that is just that's linguistic
But please, may I
trickery.
interject? But
It's not
you speak
reality.
of illogical. If you speak of illogical nonsense, but that's what we observe. That one moment we see a obstruction which is physical, and then the next day that physical obstruction is no longer there. How do we account for
No,
that, sir?
you never see the physical horizon.
No, but we see a physical obstruction, sir. We don't see the bottom of the platform, sir, because of the
Yes,
physical earth,
that's
water in the way. But the next day, sir, we see the bottom of the platforms, and the horizon
yep.
has moved behind it, sir.
That is, and I don't understand how this is inconsistent with the mechanism of refraction.
Because if it's not physical, sir, what are we calculating for?
So again, I am not claiming that the obstruction that you see, I'm not claiming that either of these images, I am not claiming that what you see in the image on the left is the result of the physical and the apparent horizon coinciding exactly. I'm not claiming that that's the case in the left-hand figure. Any optical figure you
But
see
you would
is
say
likely
to
to
me,
have
sir, you would,
non-zero refractive. Can
but
I
sir, you would
look?
say, but you, sir, because you're confusing me an awful lot here. You would say
Yeah.
the image on the left is a physical obstruction, sir. So if it's physical, will that physical obstruction, if I calculate the distance to that physical obstruction, will I get the same physical results tomorrow, sir?
No, because what is being obstructed? What is being obstructed is light from the rigs. Okay, so the path that the light takes from the rig to the camera changes depending on refraction on refractive effects. So if refractive effects change on a day-to-day basis, then that distance is going, then the distance to where you can see the bottom of a rig is going to change on a day-to-day basis.
So how does refraction move the physical behind it?
It
Behind the
doesn't
physical? How
move
does
the
the
physical.
behind the physical, sir? So you've got a physical platform. You have a physical obstruction. That physical obstruction went through the physical platform and now is behind the platform, sir. How does that happen?
Okay,
You asked about. Mhm.
so obviously, I've explained this to you 4 or 5 times. Now, either I am incapable of explaining it, or
No,
you are
you're good. You're
incapable
good.
of understanding my you are
Sir, I'll
incapable
put
of
it this way,
understanding
sir.
my
Let's
explanation.
put it this way, sir. So let's try like this. If that was a brick wall covering those piers, and I measured the distance to that brick wall, that brick wall would be there tomorrow because it's physical, sir. It's
Yes,
not light. It's not.
yes,
It's not. Yeah.
but the light would be able to get over the wall and to the camera.
hmm Okay, but the
So
Yes,
it's
wall would
not
this
the
is
not
fact that
correct.
change.
the brick wall is not
Hey,
changing position. It's staying exactly where it is throughout. And can I, again, like,
So how did the
okay,
brick wall now get
this is no,
behind
no,
the
no, no,
piers?
no, no, no,
hold
no,
on.
no, please,
I have
please,
something for
please.
this. I have something for this.
Yeah, okay.
Give me 1 second.
Again,
I'm getting it pulled up.
the interpretation of optical images is fraught with all of these uncertainties and ambiguities, and I would reject it outright.
Okay,
And
so let's just take a short break because I need 5 minutes anyway. So you guys can review what we've
okay,
said, whether you agree or not. Craig, team, I'll still be here, but let's just take a few moments because I don't want to cause too much distress. We just want a simple answer. Is that a physical, like a brick wall,
Yeah,
or is it not
I
physical?
will. I'm about to show you something right now. I'm about to show you something
All
right
right, so
now.
I'm going
So
to
you
take
take
five
your time
minutes
and let me
anyway,
know
but
when
I'll be
you're ready.
listening here, team.
Yeah,
Okay?
we'll come back.
All right,
Well,
you're
I'll wait to get back
you're
before
gonna
I.
show that when he gets back, right? Okay.
Yeah, okay. I'll
so
show this. I'll show this, and then he can. Okay. So if we go
yep,
right here, 1 second, guys. I'm sorry. All right, if we go right here and we look, in this example, this propane tank doesn't change distance, yet we can see beyond the horizon that it causes. The obstruction is there. It is obstructing what's behind it. And the moment that the atmosphere changes on top of the cylinder, then you can see what was originally blocked right there. See?
oh wow,
That
that is a
object
great
didn't
experiment.
fucking move. That
Yeah.
object that object did not move, and yet you can see things that were originally blocked.
And it's
Holy,
I think it's liquid propane which has a boiling point of 0 degrees, so it's chilling the
right?
air to about 0 degrees, and obviously that's
Hmm.
enough to create the gradient because obviously the it will be equivalent to our atmosphere, which has a gradient which it will refract to. So it's showing exactly what happened at, say, the
Yep,
Chicago observation when they say that you can't see Chicago in the distance. You shouldn't be able to see Chicago
yep,
over the lake, but
yep.
yeah, you can.
Oh,
Refraction can absolutely
that's
do that.
fantastic.
There's another video that someone made called Mr. Sensible. I just want to see if I've got it on
Yep.
here.
We'll wait till when Spurs gets back. We'll replay that video for him again,
Yeah.
but just so the audience
Okay.
can see, like Exactly what we're talking about.
Okay,
On
black
one
swan killer.
day, when atmospheric conditions are one in a certain, it's a certain condition out there, you're going to have an observation that's going to be unique to conditions. The moment those conditions change, the observation changes. You can even take a picture and say, hey, look, these two pictures are exactly the same, but if you go back and look, you might have been a little bit warmer one day with a little bit more humidity, and it just made it look to where they were very similar. But they are unique to that particular observation and those particular atmospheric conditions.
Sort of there's so much time invested into this argument. I kind of noticed that he fled at high speed away from trying to explain how planes work. If he doesn't believe in air pressure. And he can drag us into the weeds, and we can spend hours and hours thrashing through this, and it's a confusing enough collection of physical principles that at the end of that time, it seems unlikely that he's going to have learnt anything about what's happening.
Oh, this is Spurs. He's incapable of learning.
Well, you've perhaps had more experience with him than I have, but that's generally true of flat earthers. But it's just weird to me, rather than talking about any other branch of evidence, they want to go here where it's just a circular discussion of, well, I don't understand.
And this video I'm about to play is a direct response to someone in the chat. Can't remember their name now. You're so forgettable. A man like me, who's saying that the refraction, they're straight out denying that refraction can refract the position of the horizon. They're saying for some reason the horizon is immune to the effects of refraction. But this is a video by Mr. Sensible.
Yeah.
Okay, black swan killer. Over here, we have a little tack with a white paper on, a little flag. Here we've got our sphere with our platform on, and we've got this blue area which is beyond the horizon. It can't be seen on the close-up footage. So what we'll do is we'll introduce some refraction. I'll keep the camera running in the corner so you can see the whole thing. So we've got our view of the platform just in front of the horizon, the physical geometric horizon, and you can't see the blue which is beyond the geometric horizon, and you can't see the white flag either. Here comes our refraction, distortion. There's the platform, and as we change it, you can just see the blue that's beyond the geometric horizon and the white flag behind it. There it goes. Here it is. Refraction will bring things beyond the geometric horizon. Black swan busted.
Yeah. I just want to quickly throw in just how skilled you guys are at science communication and practical demonstrations.
Oh,
You managed to distill, you and Mr. Sensible and Blue Marble Science and Katz, and you had this skill to just distill it down and make it really accessible and really clear, and I'm just in awe of it because all I do is prattle on with using big words for a long time.
The thing is, we've been speaking to flat earthers for long enough that we have learnt to dumb it down as much as we possibly can. And the Rumpus said it earlier in the chat, you always have to assume they're stupider than you thought.
Yeah, exactly. That was my biggest problem when I first started, is I was speaking in a lot of technical terms, and then the immediate response you get when you speak in all these technical terms is, you're just indoctrinated. And you're like,
yeah,
but it's not indoctrination. If it's the truth, I mean, I would rather, even if it is indoctrination, that's fine with me. As long as I'm being indoctrinated with the truth, then who fucking cares? You know what I'm saying? But yeah, these guys are fucking morons. They don't understand that this is everything you learn. Just because you stopped learning science in high school when there was literally no practical application, other people went on to do science in college, and in science in college is a little bit different. They start making you do labs and sending you out to do experiments. Like if you take astronomy in college, astronomy in high school might say, oh yeah, look, these are the stars, these are the constellations. In college, they go out there and they try to get you to do stuff like take parallax measurements and angular measurements of distances between stars and things like. It's a whole different ball game when you go from high school to college. It's about practical applications at that point.
Yeah.
I agree, absolutely.
Right.
And that's one of the biggest problems that you guys do not introduce is the practical side to the phenomena that we see in that.
Saying that, Team Skeptic had a video he wanted to show you.
Absolutely, I did see the back end of that. This video here perfectly illustrates what we're trying to present as our argument. So, play the video. Let's take a look at this. We can watch and then we can have some questions.
Okay. So, the reason why I'm bringing the video up is because we can both agree that the actual cylinder itself does not move, correct? I mean, throughout this video, that the cylinder stays in one place, and your critique of what Tony was saying involved, you know, if there was a brick wall there, are you saying that one day the light goes over the brick wall and the next day it does not? And absolutely, yes, it does. And this is exactly what this video shows. When one day atmospheric conditions may be like so, and it's blocking everything below the green putty down or away. The next day, the atmospheric conditions may be more conducive to refraction, and you'll see a further distance away, something that was originally blocked by that brick wall that is no longer blocked because the light going over the brick wall is being bent down towards the observer, right here. See, that red was not visible at first.
Fantastic.
That red was not visible at first. It was simply a changing of atmospheric conditions that caused the red to, or a simulated changing of atmospheric conditions that caused the red to bend over the corner, demonstrating refraction over
Can you take a screenshot of that, team? Take a screenshot and let's, because I want you to put my picture, this, because, you know, it's very difficult to understand the argument, I get it. But we will try and figure this out. So if you just take a screenshot of exactly what we can see now, and then let's get all three images, well, my image, the two shots, and this image. And then, obviously, we can outline the problem.
I would like to ask a brief question.
Yeah.
Okay.
Absolutely. Sort that out for us.
So let's suppose that I have surveyors, and they set up monuments that are 100 miles apart. Okay, and then they go out with theodolites and they set them out in an equilateral triangle. Okay, well they set them out and they measure 100 miles on each side between the three, and then they go out with theodolites and they measure the angle from at each monument to the other two monuments. Okay, so we've got 3 angles. What will the angles add up to?
Yeah? Triangle, that's 60, 60, 60, that's 180, yeah?
Okay. Would you be surprised to learn...
But you do realise you can't...
that was a good answer, but...
Sir, you can't have a triangle on a sphere, though, sir. You do realise that.
That's exactly right.
That add up
would
to...
you be... Can I... Yeah. Which is exactly right. So when people do this in practice, they don't get 180 degrees.
Okay.
They always get more than 180 degrees. Which is what you would expect on a spheroidal Earth. Yes, that's not a triangle, but it is 3 points on Earth's surface. It's a spherical triangle.
What are you trying to say, team?
Oh no!
Yeah, so that's
I was going to let him finish.
What you should do, Craig? My good friend Bev, try thinking, is an expert in this field here when it comes to triangles.
What? I'm sorry. Yeah, Jinx, fight the flat Earth. You owe me a Coke now. Can't talk until you pay me. You just said.
Craig, look, if Sir here wants to speak about triangles, 3 angles that add up to, you know, the 180 there. So he's going to have to bring on Bev. He's the expert. He's the professional. He will be able to demonstrate
Spurs.
exactly. But
Bev, I
what I
asked
would like to
Bev
do,
to
team
come
Bev's
on
been
and
running
speak with
from
me
me.
about geometry. Hold on.
Can I
We've
give
been
Bev
trying
the
to get
link?
Bev to come on and speak about geometry.
Craig.
Yeah, but we've been trying to get him to come
Craig.
on and speak about geometry for a few weeks now, and he said he would, but he won't do it. He just will not come on. I don't
Yeah, he'll
understand.
come on if,
How did we scare you,
if
Bev?
it's-
We were actually pretty polite last time. Why are you so scared to come on and talk about science and math, man? Come on. Don't be scared. Sorry, Spurs. You brought him up, not me.
I mean,
Yeah, I mean, I think
So,
yeah,
go on.
he's willing
Tony.
to come on, I think.
okay, well, please, but, you know, do you see that that's a problem? That every time that is done in practice, you get an answer of more than 180 degrees. Do you see that that's a problem for the flat Earth?
And I can prove that. I can absolutely prove that right now if you give me a second.
Oh, hey, I've
See,
got some documents to show too. For a long distance land survey done in 1977, before the flat Earth topic was one of where all science is trying to hide the shape of the Earth. No, I have actual data that shows that land surveyors, independent of this argument, came to the conclusion that would support that the Earth is shaped like Earth.
Me too.
And
I'm
it's
just getting some up.
absolutely with measuring the zeniths between theodolites at at known distances, known elevations.
Yep.
So is it
Prior
okay
to
to send Bev a
GPS,
link?
prior to
I
anything.
can send him a link. Is that okay?
Sorry?
Because I'm going to get off to you anyway.
If you,
I
if you
just want to
want
wrap
Bev
up.
to come on and argue, then yeah, sure. I'll give you a link.
I just need to step away from my computer for a moment.
Okay.
Yeah, I've got
I mean,
things
I'll
I've
send
got
the
to do
link.
too before it
If
gets
he
too
comes
late.
in.
So I'm probably gonna have to get off myself.
Well, Bev
Yeah,
can
it's
certainly
late,
argue
yeah.
with Tony. Let me just get a link for him. If Bev
Yeah,
comes,
I mean
Bev
Tony
comes
Tony
on,
can handle Bev.
Bev
Bev,
comes
the challenge still
yeah.
is
Only
Yeah,
if
Bev-
he agrees to debate Team about geometry on Team's channel.
And we don't have to leave it at just geometry. We can debate on geometry specific to the shape of the Earth. I'll leave it at just that.
Spurs, tell Bev he's got a link in his Twitter inbox.
And if
Okay,
you want to get
I
brave, we
think,
can talk about the geometry of space-time.
He's
Oh,
listening, so I
goodness me.
think he'll get that. So look, can we just get these images up then, because we can wrap this up then, and we can explain.
right.
I
Yeah.
sent it to Craig. I
Yeah,
sent it to Craig.
One sec. Yeah, that one.
Yeah, I've got about 5 to 10 more minutes, Craig, before I have to get off. I've got to be somewhere before 9 p.m. tonight, and it's right down the street, but it's getting real close to that time.
Is your pimp putting you to work?
No. That's I have off Friday nights.
You have off Friday nights.
I'm sorry. You're expecting people to pay money?
I know. This is the problem. Team is.
Have you
not a very
seen this
good
fucking
prostitute.
face, guys? Spurs. You've seen my face before, yeah? You've seen my face
I've
before,
seen-
yeah?
Yeah,
I have.
Okay.
We've
Whether
seen it.
I'm
It's
your cup
terrifying.
of tea or not, people would pay, wouldn't they? Don't lie.
For it to go away. Yeah, definitely. And guys,
No, shut up, fight.
Team,
We're talking to the intellectual here.
One sec. To my new subscribers
Please,
that have come over from Simon Dan, this is the face we're talking about.
Well, I judge by the character. I'm sure when Team realises the Earth
Exactly.
is there, not a globe, he'll be fighting the globe just as much as we are. So
Team's never.
we'll see you on the other side there, Team. Shortly.
That
After this
doesn't
explanation.
that doesn't answer the question about my street value. So would people pay? Not necessarily you, but
Important
people in general,
scientific
when they see
principle.
that face right there, they would pay, wouldn't they? They'd drop some dollars
Yeah.
on that face.
For it to go away.
Make it rain on
Definitely. That's the
I
face
love
you
you
would pay
too,
for.
Spurs.
Yeah.
Thank you very much.
Absolutely.
Exactly.
Right.
You pay for that shit.
Spreading the
Looking's
love.
free,
Spreading
touching's gonna cost you.
Right, here we go.
In all-
This is what you're asking for.
Fantastico. Okay, so, sir, we've got
Yep.
a physical obstruction with the pipes and the plasticine. Yes, physical obstruction.
Yeah.
And we're causing refractions for the object to refract over that. We could say, would you describe that as a horizon? What would you describe that point where the pipe and the air,
Yep.
the atmosphere
No,
meets?
let's call that a horizon, sure.
Let's call that a horizon. So that point, sir, from the observer will never ever change. We could measure that. That will stay there. It's physical. Same as the picture on the far left. That should stay there
No.
because it's a.
No.
Well, let me just clarify how I understand it. So, the picture on the right, far right, picture on the far left is causing a physical obstruction. Physical, not an atmospheric one. We can't see the bottom because it's been obstructed. Now, refraction will bring the object over the object on the right and should do with the object on the left. But what we find is that if he were to pour the liquid on the object on the right, the horizon would move behind the object and the object wouldn't refract over the horizon. We've got this in reverse, sir. How do we explain that?
So, look, I can only tell you that what you just said makes no sense.
So what we've got, sir, is reverse. We've got horizon refraction.
No, you don't understand. It's not the case that I don't understand what you're saying. It is the case that what you are saying doesn't make any sense. And you repeating
what does the picture on the right illustrate, sir? What is the point of the image on the right, sir? Why demonstrated the image on the far right? What's the purpose of that, sir?
The purpose of the image.
On the right, sir. What are you demonstrating on the far right, sir?
To show that things can be refracted around the horizon.
Yes, that was the purpose of that video, is to show that light can, in appropriate circumstances, refract around obstructions.
So you're showing that object can refract around a physical obstruction.
The light from an object can refract around a physical obstruction.
Okay. So that physical obstruction did not move, sir. The pipe, sir, didn't move. So why did the physical obstruction in the real world on the far left, why did that move, sir? If it's physical like the pipe.
It didn't.
It didn't move, sir. So what happened, sir? Why is it behind the platforms?
Because the light got refracted.
So you seem to be having a lot of at this stage. I have presented the explanation several times, and we are simply failing to communicate.
I'm trying to say this extremely slowly. The pipe is physical. The measurement from me to the pipe will never change, sir. From me to the horizon of the pipe will never change. Never, ever change.
Yep.
Okay? But the object, sir, the distance, the appeared distance can change. It can look like it's closer or further, sir, because of refraction. Yes?
Yes. Yep.
So, the picture on the far left, sir, the horizon, the physical horizon has moved, sir, not the object, sir. We're looking at two different things, sir. We've got the object on the right moving, but the horizon on the left moving, sir. How is this happening?
Can I show you a video that someone has sent me quickly, Spurs?
Well, I'd rather an answer from sir of how we have two opposing images and observations. One is the object over the horizon, one is the horizon behind the object, sir. How do we get the pipe behind the object?
So you are not moving the pipe. And it is the most, what you are observing is refraction of a different character.
What kind of refraction is that?
Well, it's So in the example in the video, what you're observing is a very narrow, discontinuous set of atmospheric conditions that only show a strip of what's over the horizon. Whereas in the atmospheric case, there's a continuum of refraction that makes the object, that makes the vista appear continuous over the. So that there's minutely different refraction paths for each of the light beams from along that line from you to the apparent horizon. Now, there is nothing in those images that suggest that the obstruction has moved, and you can assert otherwise as much as you want.
I'm not asserting, sir. I'm asking you. We see the bottom of the platform, sir. How is that possible? You didn't go higher.
Refraction.
Okay, can I interrupt real quick?
Shoot.
Just real quick.
Sure.
But the object,
Okay, so
the object didn't.
yeah,
The object didn't.
here,
The
Spurs,
object
one
didn't
second.
move, Craig. You say refraction, but the
Okay,
object,
but
just like
Spurs,
the plasticine,
Spurs.
did not move.
No, the apparent position of it.
Spurs, let me
Go on, team.
let me explain something real quick. Will you put the image that I sent you up real quick?
Where did you send it?
Okay, now in this image, no, I sent it to
Where-
Fight.
where-
He knows what I'm talking about. It's the image,
Oh.
the screenshot you told me. The screenshot you told me to take. Okay, so let's
Yeah.
imagine from the top from the top of the cylinder. Do you see where the red stops? See, the red is continuous. Because of how this experiment is set up, it's not a gradual changing of temperature and pressure and density going up away from the top of the cylinder. It is when there's nothing poured on it, but once something is poured on it, it changes the density right there. So it's kind of a little bit misleading because the red doesn't go all the way up. You don't see the full can. If the entire atmosphere above the cylinder was, the same, analogous to to what is right on top of the cylinder, then you would see the whole can behind it. But that's not the point I want to bring up. The point I want to bring up is that if you were to take this image right now and put a point at the top of the red, okay, and you were to take a string from that point on the can to the cylinder, all right, we'll just say that string right now under these conditions would be visible. Now, when the conditions are normal, that white string would not be visible. So
Sure.
it is lifting not just the one object behind it, but it's lifting all the light that's coming from anything, even the light from between the canister and the can and the canister. Even the light between that is being refracted, but there's just nothing to see there. So if you were to take a white string or a white plane or anything that you want and were to line it up in this orientation right here, then when you remove the refractive index, you would not see that line anymore. You wouldn't see the plane. You wouldn't see anything there because then it would go back to being blocked by the cylinder.
Okay, that's fair enough. Again, this is not being disputed. You're bringing the
Okay.
plasticine
So-
back over that curved pipe, right? You're bringing it back.
Yeah, but it's
with
also
the
if we had something physical, but if we had something physical that ran from the cylinder to the canister behind it, it would be bringing all of that over to see.
Again, I'm not disputing that because that pipe will never
Well,
ever
that's what
change.
we're seeing.
No,
But
what
if
we're
you go
seeing
to the
in Black
other
Swan,
pictures
what
that
we're
you were
seeing in
showing,
Black
the one that
Swan
had the one that had the high refraction. Okay, go ahead. I'm sorry.
But what we're seeing in the Black Swan, is the horizon moving, not the object. The object stays in the same place, but the horizon has moved behind it, not the object. You keep on talking about the object. The object stays
Right.
where it is.
Right. So when I said that if we drew a white line from there to the thing, then that would literally be like an extending apparent horizon.
No. You
Because
can't
when it's
draw,
gone,
you can't
the
draw
apparent
a line.
horizon comes back to the
Yes, but
cylinder.
hold on, T. You can't draw a line to the red because it's not in line of sight in reality, is it? It's refracted.
No, 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 no. What I'm saying is, let's say we stop this picture right here, right? And we picked a point on that canister that's in the red, all right? Now, I'm not saying draw a line, a physical line from here to that point that we're seeing. I'm saying draw it to the point on the canister. So really, it wouldn't be going straight up like it is with the line of sight of the camera. It would really go kind of down. The only reason it looks like it's up is because it's being refracted over the canister. It would only look like it's pointing up. The actual physicalness of the line would still be pointed down, relative to the way the camera's pointing. It would be pointing down to the canister. Something that would represent a light ray that could make it that an observer would see if he lifted his camera up, but would be blocked by the cylinder when it's lower.
Again, this is not the argument, team. You're arguing for something else.
No, it is. You guys strawman the argument. This is what we say.
We're not disputing that this happens. This is what should happen on a globe. You have a physical horizon like this. No, this is what should happen. You should have a physical horizon like this that never ever changes its location. So if I come back tomorrow, that horizon from my distance should be the same.
No, because the horizon can be refracted as long as there's everything else. Let me just quickly show you a video.
The horizon. Where's the horizon in this image that you've got up?
The geometric horizon can be calculated quite easy. But watch this video, all right? All right, the physical horizon doesn't move position, but you induce some refraction, and all of a sudden the horizon is behind those platforms. That's exactly what refraction does.
Where's the horizon here?
Well, it showed you where the horizon was when he takes that away.
It's the line where the water meets the sky.
So you can see the horizon.
Hold on a second.
Look, that's the horizon right now, yeah?
No, that's not correct.
What is that then? What's that line there?
You've just shown me a geometric hard horizon without atmosphere. That's not what happens in reality.
No, there's still atmosphere there. But what we're doing... But what we're
doing...
There isn't. Yeah, right, but what the point of then inducing the refraction is to show you that refraction can change the apparent position.
No, but that is still the geometric physical horizon.
But the apparent position of it has changed. The apparent position of the horizon has gone from being in front of those platforms to being behind those platforms.
No, we don't see the geometric physical... No, because we don't see the geometric physical horizon. We see the apparent horizon outside. That is a geometric edge.
A horizon?
That would be an edge, yeah, a point you can mark that will never ever change.
You don't have to be afraid of saying the word, that's a horizon.
But it's a point we can measure and that would never change. So from that point onwards, from that point onwards, Spurs start to drop away. That's what you forget, you see.
And it does. That's what would happen after this horizon, the Earth would drop away. However...
No, so the picture on the left, from that horizon, Earth would start to fall away.
Purely by refraction, the horizon is now behind those platforms. The physical position of the horizon has not changed, but the apparent position of it has because of refraction.
Yes, and I said, when you see the horizon, things are dropping behind it. So that means the Earth is falling away. That can never change. Okay. That would be the same every single day.
Yeah, but the apparent position of what's going away can change.
I'm going to come at this with. I'm going to come at this from two different.
Well, it's going to be the last point because I'm going to have to go now. So.
Okay.
And Bev has come in, so Bev can talk to the PhD in a second.
2 points. One, are you one of the top 30 intellects on the face of the planet?
So it's not about me, sir. It really isn't. I don't profess to be.
Are you? Okay, so there are people who are more intelligent than you out there. I suggest you find one and get them to explain this to you. Now,
I'm speaking to one right now.
So I have a PhD. I have also represented my country multiple occasions in mine sports. So when we get to a situation where you're saying you don't understand something and I'm saying you don't understand something, I am going to conclude on the basis of the evidence available to me that actually you're the person whose understanding is uncertain, and I'm going to try and help you out as best I can. But you seem to have this this refusal to accept, because you haven't changed your positions. We've been discussing this for the better part of an hour, and you just haven't changed at all. You have not accepted, and this may be, I don't know how to explain it,
No, it's
but
not
you're
you.
going to have to
Cool.
find somebody you trust, whose authority, whose intellectual authority you respect, on a genuine level, and talk to them about it.
But he's going to choose
Because
another flat earther.
please believe me, you are wrong, and I don't know how to say it gently.
That's absolutely fine. So I appreciate the time that you've spent, and hopefully we can do this again some other time. Craig, Team Skeptic, it's been a pleasure. Go ahead,
I
sorry,
would like
sir.
to
Yeah,
say
same
that
Spurs.
I
Hey, man,
I would like, please, you can call me Tony. Honestly, it feels very unnatural for you to call me sir.
He's doing
Just
it
call me Tony.
facetiously.
Yeah, well, again, I'd prefer he not do it if it's facetious. But the other point is that you've been very civil, and thank you for the discussion.
Thank you very much. Thank you very much, Tony, as you prefer to
Hey,
before. So, guys, I will catch you
Yeah.
all later on. We'll do this again, Team.
Bye,
Craig,
Spurs.
don't be
Okay.
scared
have
to
a good
come hang out
evening.
on my channel, Spurs.
Will do. Have a good evening.
Yeah, well done,
Okay.
Spurs. Good job.